We can also work to solve quadratic inequalities algebraically or symbolically. In order to solve a quadratic inequality, we first need to write that inequality in standard form. And standard form for our quadratic inequalities, ax squared plus bx plus c, inequality symbol, 0. So we could have any of the 4 inequalities in that box, but the big picture is we have 0 on one side and everything else on the other side. Exactly like our standard form for quadratic equations. We want to solve the related quadratic equation in order to get critical numbers. The critical numbers are the zeros of the quadratic equation, or better said, x values that make our quadratic equation. We're looking for the x-intercepts of the graph. So we'll use our techniques for solving quadratic equations, factoring, square root property, completing the square, or quadratic formula to solve those equations and get these critical numbers. We'll put the critical numbers on a number line. That number line is representing the x-axis. And then remember, we're not graphing in this technique for solving, we're doing it algebraically. So instead of graphing the parabola and seeing where the parabola is above the x-axis or below the x-axis, we're going to be plugging in test numbers that are in these intervals. We'll only have to test 3 of them. We'll plug into the original inequality to determine if the inequality is true or false. And then the very last step is to determine whether the endpoints of the intervals are included in the solution set. That all comes down to which type of inequality we're solving for, whether it's a less than or equal to, greater than or equal to, those equal to's meaning we include the endpoints, or strictly less than, strictly greater than, we don't include the endpoints. Let's walk through number 3 together. X squared plus 3x is less than or equal to 18. Our first step is to get it into standard form, so we're going to subtract 18 from both sides. X squared plus 3x minus 18 less than or equal to 0. We don't need to change our inequality sign because we did not multiply or divide by a negative number. We only subtracted. Subtracted does not change our sign. Now we need to solve the associated equation. I'm going to change the color. I need to solve this equation. I could use completing the square. I could use the quadratic formula. I'm going to use factoring because I see a factoring pattern that's evident. 2 numbers that multiply to be negative 18 and add to be positive 3 would be 6 and negative 3. So I have plus 6 minus 3 in that factoring pattern. Solving for x in this equation will give me negative 6 and positive 3. Now that I have these critical values, which are what these are called, the zeros of the quadratic equation, or the x-intercepts of the quadratic equation, I'll create a number line. 3 somewhere on the right, and negative 6 somewhere on the left. It doesn't really matter as long as we have them in numerical order, smallest to greatest. And then the next step is to pick values, one value less than negative 6, one value between, and one value greater than 3. If we can pick 0, 0 is always a good one to pick because using 0, we can get a fast result. For the other numbers, it doesn't really matter what we pick. I like going only one nearby, so I kind of keep my numbers pretty small. And we're going to take each one of these 3 numbers and plug them back into the original equation and determine which ones make the inequality true or false. Starting with x equals negative 7, negative 7 squared plus 3 times negative 7 less than or equal to 18. 49, 3 times 7 is 21. 49 minus 21 will give me 28, and that is not true. Negative 7 does not make the inequality true. I'll change my color and plug in 0. 0 squared plus 3 times 0, is that less than or equal to 18? The whole left side turns into 0. 0 is less than or equal to 18. This is true. And then plugging in 4. 4 squared plus 3 times 4, is that less than or equal to 18? And when we plug in 4, 16 plus 12 will get us 28, which is not less than or equal to 18. To solve the inequality x squared plus 3x less than or equal to 18, we're looking at the interval between our critical values, -6 to 3. And we include the endpoints because we have that equal sign. So another way to include the endpoints is to use brackets. And this is our solution for the first quadratic inequality. Something to point out, if we are relating this to the graph, notice that x squared plus 3x minus 18, if I were to graph that parabola, I would have a parabola that opens up. Also, one of the zeros would be at x equals 3, and the other would be at -6. And we're looking at less than or equal to, and so that's going to be, the less than or equal to is going to be below the x-axis, which is the interval of x's between -6 and 3, according to the graph. So it makes sense that the -7 and the 4 did not work, as they are above that x-axis. I'll leave number 4 for you to try on your own. If you want to check your answer, you can pop over onto the OneNote. Taking a look at number 5, 8x squared minus 2x minus 3 is greater than or equal to 0. I can first find those critical values, and I'm going to use the quadratic formula this time just to be different. I don't see a very visible factoring pattern right away, so I will set up my quadratic formula. First I identify A is 8, B is -2, C is -3, because I already have my inequality in standard form. And we look at x equals -b plus or minus square root b squared minus 4ac all over 2a. A is 8, b is -2, and c is -3. Simplifying, +2, -2 squared is 4. 4 times 8 times 3. 4 times 3 would give me 12. 12 times 8 is 96, and notice I have two negatives here. So that's going to give me a positive. Divided by 2 times 8 is 16. And 4 plus 96 is 100. Square root of 100 is 10. And I have 2 plus or minus 10 divided by 16. 2 plus 10 over 16. 12 over 16 will be 3/4. 2 minus 10 over 16, -8 over 16 would be -1/2. So I have two fraction answers for my critical values. Plotting these on the number line, 1/2 negative, 3/4 positive. I can pick my three values between them to plug into our original inequality. And I'm not limited by what values I pick, I just don't want to pick those two. I can pick any other number. So I'm going to pick 0. I love picking 0. -1/2, I could pick -1. And 3/4, I could pick +1. I just want to pick one value in each one of these intervals in order to check. So let's start plugging them in. If x is -1, 8 times -1 squared minus 2 times -1 minus 3 is greater than or equal to 0. 8 plus 2 minus 3, is that greater than 0? 10 minus 3 is 7. Yes. Plugging in 0. 8 times 0, 2 times 0, 0 squared. Greater than 0, question mark. 0 minus 0 minus 3, I get a -3 greater than or equal to 0. This is false. And x equals 1. Noticing the pattern that happens with quadratics, since the outside interval works, I'm expecting this outside interval to also work because of the symmetry of parabolas. But let's double check and make sure. 8 times 1 squared minus 2 times 1 minus 3, is that greater than or equal to 0? 8 minus 2 minus 3, 8 minus 5 would give me 3. And 3 is definitely greater than or equal to 0. So I do have that inequality to work. To write our solution, we would have -infinity up to 1/2, -1/2. I'm going to include the endpoint because of that equal to, and then 3/4 up to positive infinity. And that will be my solution for number 5.